and turn on live captions. So everybody give me a thumbs up if you can see my screen. Okay, good. So here's one of the questions. I went ahead and pulled up one. Well, I thought I did. Go ahead and write this down right here. Step number 3. They're going to give you a table in one of the questions or in some of the questions. And I want to make sure you understand how to do the table. It's called the critical value. So it says if the absolute value is greater than the critical value, then you have a correlation. Now that means a positive correlation or a negative correlation, depending on what kind of correlation you have on the scatter plot. So I'm going to show you how to do one of these problems, and therefore one or two of you can go to the video while the other 13 say that you don't know how to do it. Okay, that's what the other classes do. So I figure y'all just follow suit. Yeah, I got one. I was telling the others that just came in. I was telling the others that I've got 2 or 3 students that are sending me homework questions by taking pictures of them and sending them to me via email. Am I going over them? Hell to the no. If you're not going to follow simple ass directions, I'm not going to help you out. I just don't understand it. I didn't get any questions out of this class. I'm going over this homework question just as a precaution because I know somebody will have one of these homework questions, and I'm going to go ahead and address it now. So if you're given a table and they ask you to determine, it's called a correlation test. So you might want to say correlation test in your notes. If they give you a table, you count the number of points you have, and that gives you what's called a critical value. And that critical value is going to be a 3-digit 0.782 or 0.667. Okay? And then you test your line of regression either by TI or by the Excel spreadsheet, and you come up with a correlation coefficient that the absolute value is higher than the critical value. If it's higher than the critical value, then you have a correlation. So with that being said, let's go to a homework problem so I can go ahead and, there it is, right there. So I'm going to let you write this one down. It just says, okay, here's the data set. So I'm going to give you the data set. And there it is. I'm going to put it in the Excel spreadsheet so you can see it. Excuse me. And I'm going to blow it up for you. So go ahead and either put that in your Excel spreadsheet or put it in your whatever you have, TI or whatever. Go ahead and put those numbers in. Okay, so there's your points. So you go ahead and do whatever you need to do, and I'm going to go through and I'm going to do insert, and I'm going to draw a chart plot, and I'm going to make it big where everybody can see it. And there is my chart plot. Somebody tell me what kind of correlation we have, a positive correlation or negative correlation?
Positive.
Yes. So therefore, on this problem, I know we have a positive correlation. So with that being said, it doesn't matter what my absolute value is or what it is to the critical value. We know if we test right, we're going to have a positive correlation. Same thing with a negative correlation. So with that being said, we know the answer is going to be, if it's a correlation, it's going to be a positive correlation because of the layout of the dots. So I'm going to do right click, add trend line, go down and hit display and display. And there is my equation. I'm going to blow that up for you. So y is equal to 2.5625x minus 1.8125. R squared is equal to 0.9057. So let me go over here and do R is equal to, and I'm going to raise 0.9057 to the 0.5 power. And R is equal to 0.95. R is equal to 0.9517. Now that could have easily been a negative R. Okay, it could have been a negative R. And this is what you do with your R, no matter what sign it is. Okay? You take the absolute value of 0.9517, and if it's greater than the critical value, then you have a positive correlation. If it's less than the critical value, then you do not have a positive correlation. If we started out with a negative correlation, we'd have a negative R value. You would take the absolute value. If that absolute value was greater than the critical value, then you would have a negative correlation. So whatever you start off with here, you're going to end up with here, no matter what these numbers are here, because you're going to take the absolute value. Okay, this right here is the test. So they don't take into effect the positive or the negative. Okay, there's no positive or negative in this test. I can't even write positive or negative. There's no positive or negative in this test. All right, so let's go find our critical value. How many points did we have in this problem? 1, 2, 3, 4, 5. So n is equal to 5. N is equal to 5. So we go to our table and we look in our table and find 5, and 5 is 0.878. So n is equal to 5 gives us 0.878. 0.9517 is greater than 0.878. Therefore, we have a positive correlation. And I'm just going to add the absolute value there. All right, so I'm going to do another one now. And this problem on the spreadsheet is going to be a negative correlation. So this was a positive correlation. We tested it, therefore it does have a positive correlation. Boom. So let's do a negative correlation. Let's go with the problem we're doing, and let's change the numbers. I'm going to delete this. And I'm going to change these numbers, and we're going to change them around 18, 14, 11, 5, and 4. Okay, so the first thing we do is we highlight it, and we send it to insert. And in this problem, oops, did I do? I think I did. Yeah. Here, what kind of correlation are we going to have? Hello?
Negative.
Negative. It's going left to right down. So we know we're testing for a negative correlation. So I'm going to add trend line. Go down and hit display and display. Make this a little bigger for you. Okay, so I'm going to type in 0.8569. And I have a correlation of 0.9257. So y is equal to negative 2.75x plus 24.15. R is equal to negative 0.9257 because it's a negative correlation. So we're going to test the absolute value of negative 0.9257 and see if it's greater than 0.878, and we know it is. So 0.9257 is greater than 0.878. Therefore, we have confirmed that we have a what correlation? A negative correlation. So when you test using the absolute value, you're testing to see if you have a positive correlation or if you have a negative correlation. What will tell you what correlation you have? Well, you're going left to right down, or you're going to what? Left to right up. That's a positive slope. That's a negative slope. And the relationship between the slope and the correlation is the signs. Positive slope, positive correlation. Negative slope, negative correlation. So whether you test, whatever your test is, you're testing to see if this holds true. You're testing to see if this holds true. The positive and the negative correlation comes from the slope. Capiche? The reason I needed to show y'all that was because that's the question on the homework that usually gives y'all the most problems. And I guarantee you somebody's tried the homework and you didn't do that problem because you didn't know how, or you didn't know what the big deal was. But you didn't send it to me. I don't know why, but I went over it for you. Capiche? Okay, and that's on video for the 2 people that watch the videos. Okay. Let's go with another homework problem. Let's see, and that is a test question, so. And that could be a test question. Most of these are pretty simple. I'm looking for the, let's see. All right, let's do this one. All right, I'm gonna let you, I can't blow it up, I'm sorry, but I'll tell you what it says. Lyme disease is an inflammatory disease that results in a skin rash and flu-like symptoms. It is transmitted through the bite of ticks. The following data represents the number of reported cases of Lyme disease and the number of drowning deaths for a rural county. Complete parts A through C. This is a test question, so here is Lyme disease and drowning deaths. So I'm going to put those in the Excel spreadsheet so you can see them. There you go. Now I'm going to pull, first of all, I don't like the way this is written. First of all, I'm going to pull the month. I'm going to Control X. Oh, I hate my mouse. Control X. And I'm going to insert. Well, I guess I'll just put it. I want to insert. There we go. That's a whole lot better. All right, everybody with me? I'll give you another second or two to write that down. Everybody should be writing. Yesterday, I had a student at Crescent. He just sat there and looked at the screen. I'm like, are you not going to write? I guess he's one of those people that already know everything. Y'all don't have any of those people at Palmetto, do you, that know everything? Nobody's going to say anything. Now, what I'd like for you to do is maybe plot these in your calculator, and you would have to maybe call January 01, 02 for February, 03 for March. You would have to do it like that. I don't know if it would take it, but I'm going to see if I can do this. Insert. There we go. it went ahead and called the months by the, and this is Lyme disease. Oh, come on. Lyme disease, thank you. And I'm going to put that over here. And I'm going to go down here and I'm going to copy this one. Control C, put it right here. And Control C, Control X, and Control V. And I'm going to do a graph of the drowning deaths. Insert chart. And I'm going to move that after I title it so I don't mix them up. And I wish I could show them both to you at the same time, but I'm going to add a trend line, and there is a linear, and I'm going to hit display and display. And there is the information for that. And then we'll go down here and do the same thing. So, let's do correlation equals 0.0148 raised to the second power, or 0.5 power, and equals 0.006 raised to the 0.5 power. So there's a slight correlation with both. So I would say if I'm going to assess these two, since 0.12, 0.12 and 0.08, since 0.14 and 0.08 are close, not very close, but close, we have similar correlations. 2, does this mean causality? If you go swimming, or if you go hiking, does that mean you're going to die of Lyme disease? Or if you go hiking, does that mean you're going to die of drowning? No. What do we have, though? Can anybody tell me what we do have in this example? what we have is called a lurking what? Variable. And somebody tell me what the lurking variable is. Anybody? Anybody know what the two have in common? I mean, one's on land, one's in the water. They have nothing in common. Yeah, they do. What they have in common? Look at the graph.
They go up when the temperature is higher.
Keep going.
The temperature's
Keep going.
hotter.
If what?
The temperature is hotter, so people are hiking and swimming.
So the lurking variable is what? Warm weather months. Now, this is what you need to be able to do with a problem in 4.1 and 4.2. Get a little bit of common sense here. We've got some correlation similarities, but does that mean one causes the other? No, but the lurking variable causes it. The lurking variable causes the causality. The warm weather months cause an increase in Lyme disease and what? And drownings. So, although there's no causality between the two, there is causality from a lurking variable, which is the warm weather months. Is this a test question? Oh, yes. Is this a standardized test question? Yes. Why? Because it can tell if a student has common what? Common sense. So I thought I'd show you that one. You're welcome. All right, let's move on. Let's move on to 4.2. Find one that I like in 4.2 for a test question. Well, I lost my test question, so let's just go back to assignments. And 4.2. And let me find one that I would put on a test. Well, I'm trying to find one, but I don't think. I thought there was a slope and a equation question in here, but I guess there's not. Well, let's see what this one says. The data represents a total compensation and company stock performance for 12 randomly selected chief executive officers. Explain why it does not make sense to find the least square regression line. Click to view the data. So there is, so let's go to the Excel spreadsheet. And I'm just going to do, I don't care about the returns. The compensation is what so I'm going to highlight those. and I'm going to draw a scatter plot, it will probably put a number for these right here, and that's fine. You want to see what it looks like. And right click. Well, a little bit of a negative regression. It's around 0, so you need to at least find the R value. So equals 0.0889 raised to the 0.5 power. So you got a correlation, a negative correlation, but what's the critical value? How many points do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N is equal to 12. So let's go see what the correlation coefficient, the critical value is. Critical value for 12 is 0.576. So in this problem, 0.576 is the critical value, and we had a correlation of what? Point what? 0.298. Is 0.298 greater than 0.576? No. Therefore, you do not have a correlation. Okay. So that's just a continuation of what you learned in 4.1. I thought for sure they'd give you a slope question. So anyway, all right. So with that being said, let's move on to chapter 5. Since nobody's sending any homework questions, that means that everybody either is not doing it or they understand it. So I'm going to move on to chapter 5. Now, y'all live on the north end of town, so I don't know if many of you know about Wild Hog Road. And this is chapter 5. I always talk about this with chapter 5. Wild Hog Road is Highway 187 that goes to Pendleton. And when you get on Wild Hog Road, let's see, I'll try to draw this best way I can. Here's the double bridges. And if you're from Anderson, you know what the double bridges are. If you're not from Anderson, you don't have any idea what I'm talking about. But there's the double bridges. There's 2 of them, and they're 2 long bridges. And there they are, 2 bridges. I'll color them black so you'll know where they are. And this is Highway 24. And this is Wild Hog Road. Wild Hog Road dead ends into Highway 24. And it goes to Pendleton. And it ends, and whatever you want to call that highway, Clemson Boulevard or whatever, the Waffle House in Pendleton is right here. Pendleton High School is right here. So I don't know if you know where it is now, but that's Wild Hog Road. People from Anderson call it Wild Hog Road. People that are not from Anderson, transplants, call it Highway 187 North. Highway 187 North, because Highway 187 South is down here. So anyway, to make a long story short, when you get on Wild Hog Road, it usually takes you around 15 to 20 minutes to travel it. Now, I do know that there's some guys in here that can travel it in 2.6 seconds. But most people that have sense can travel it in 15 to 20 minutes with no traffic. Okay? It's a long stretch of highway, and it's hard to pass because there's so much traffic on it. And, it's just one of those roads. So that means it takes you about 15 to 20 minutes to travel it, except when you're in a hurry. Because when you're in a hurry, the little blue-haired ladies club comes out. And as soon as you turn on to Wild Hog Road, there's one of the blue-haired little ladies right there. Now, how fast does the blue-haired ladies club travel? 33.5 miles per hour, because you can turn your cruise control on after 30 miles an hour. So they push the limits, and they put it on 33.5. All right. So you're going 35 miles per hour. Now, some of you that think you're important, you're going to try to pass, but you can't because you might have a head-on collision. And those people that can go the speed of light, guys, that think they can go the speed of light, they usually can't pass either. So you're stuck. You get up to the red light, and you get about, 200 feet from the red light, and you say to yourself, I bet this woman is going to turn left. And what happens as soon as you say that? Her left blinker comes on. How many people have done this before? How many people have gotten behind a car and predicted the future? Did you predict the future by saying this car is going to turn left? Did you predict the future, yes or no? That means I want somebody to say yes or no. Anybody? I had 5 people raise their hand, and not a single one of them are going to say whether they told the future or not. No, you did not predict the future. I'm going to tell y'all a little secret. No one can predict the future. No one. If anybody ever tells you they can predict the future, all you got to ask them is one question. Somebody tell me what that question is. Oh, come on, people. What would you ask a person that could tell the future? If they legitimately could tell the future, what would you ask them?
What's the lottery numbers?
There you go. Good job, Miss Poor. How did you know that, Miss Poor? You just think in terms of money all the time, or what?
100%.
What?
I think in money, 100%.
There you go. Most people do, all right? And then the person would go, oh, that's not what I do. No, you don't, because you're a fraud and you're full of crap. Nobody can tell the future. How many of you have played 20 questions before? Okay, Miss Landreth or Miss Woodson or somebody that's played it. Give me a rundown of how you play 20 questions.
You just ask questions back and forth to each other.
Until you find out what the other person is what? Thinking about, right? That means you can read minds, doesn't it? No. You use what? You use deduction to find out what the person's thinking about. All right, I'm thinking of okay, we're going to do this right now. Somebody's going to bitch about it, so I know that. I'm thinking of something right now. Let me put my hands on my head so y'all can read my mind. Okay, we're going to ask 10 questions. Somebody ask a question.
Is it in the room with you?
No.
Can you buy it at the store?
No.
Is it math related?
No.
Is it sports related?
Is it what?
Sports related?
No.
Is it alive?
Yes.
Is it a cat?
No.
Is it a
Okay, you broke up, Miss Landreth. What? Okay, somebody ask another question.
Is it a mammal?
Yes.
Is it your son?
No.
Can you eat it?
What?
Can you eat it?
I guess you could. Never heard of it being eaten before. We'll go to 20 questions.
Can you hunt it?
Can you hunt it? Yes, but people would put you all over the news for it. That's 10.
Is it human?
No.
Is it a dog?
No.
Is it large?
Yes.
Is it an elephant?
No.
Do they live here?
No.
Is it a giraffe?
No.
Does it live in Africa?
Yes.
Is it a zebra?
Bingo. You just read my mind. I don't believe it. Mr. Hamby, can you read people's minds?
No.
No. How many of you have ever seen at the carnival or fair or whatever you want to call it, fortune telling? How many of you have seen that before? First of all, I'm going to tell you a little secret. There's two people that walk into a fortune teller's building or whatever. People that are already depressed about their life, or people that want to see what it's all about. Inquisitive, curious people. Once you step in, the fortune teller knows you're either curious or you're depressed. What are they going to start doing? Are they going to start telling your future right from the get-go? Or are they going to ask you questions? They're going to ask you questions. And they're immediately going to say, someone is going to come into your life. Well, they've already found out through asking questions that somebody dumped you like a year ago or 6 months ago. They're going to find that out. And then they're going to find out that you lost your job or you got fired or something, and you're going to come into some money. You're going to come into, you're going to get a new job, and you're going to come into some money. Yeah, usually when you get a job, you come into money, you get paid. All right? So, what am I trying to tell you? That usually when you're talking about predicting the future, it can't be done unless you use a little bit of logic or a little bit of what? Deduction. What are you talking about logic, Hubert? Does anybody know anything about West Anderson? Anybody know anything about this area out here?
It's a little shady.
Oh, come on now. You're talking about Southwest. You're talking about LA. You're talking about Homeland Park. I'm West LA, okay? out here near Sadler's Creek and Highway 24, you know, we're not shady out here. All right. The only way to get to Pendleton and Clemson is through Wild Hog Road, or you got to go through Centerville to get Clemson Boulevard. It's the only way you can get to Pendleton. So if you're on this road and you're going in this direction, chances are you're either from Townville or you're from West Anderson, but you're not going to be from Townville because you can hit 85 and get off at Wild Hog Road and be there in, you know, half the time. All right. So, because 85 goes right through here. Now, the whole point is, if you're from West Anderson, if you're on this road, you're heading toward Pendleton or Sandy Springs. Now, how did I know that that person wasn't heading toward Sandy Springs? Anybody that knows Wild Hog Road? Does anybody know Wild Hog Road enough to tell me why I know she's not going to Sandy Springs? Because you turn right to go to Sandy Springs. How do I know she's not going to Sandy Springs? Because on Wild Hog Road, there's 3 different ways to go to Sandy Springs by turning right. So if I'm past Pendleton High School and this person has not turned right all the way down Wild Hog Road, where is she going? She's going to Pendleton. What did I just use there? I didn't use deduction. I used what? Logic. Now, what am I trying to get across to you right now? You are not telling the future. What you are doing is you, write this down, are assigning a number between 0 and 1 to a prediction based on logic, experience, or mathematics. Now, the logic, you can use deduction if you want to. That's okay. Now, did you tell the future? No. Did you read my mind? No. Or did you use a little bit of probability? And that's the definition of probability. The definition of probability is assigning a number between 0 and 1 to a prediction based on logic, experience, or mathematics. In other words, stats. That is the definition of probability. So you learned 2 things today. You learned that if somebody can tell you they can tell the future or read your mind, they're full of what? Crap. You also know that logic, deduction, experience, and mathematics can tell you what may happen. I said may, I didn't say certain. What may happen with a prediction. Question on that. Now, is that important? Yes, because this right here is a test question. So make sure you read the definition in the book. It's a hold your pinky up definition. Let's go look it up so everybody can see it. Let's go to 5.1. And show y'all the definition. Well, I thought we were going to get a definition of probability. I guess not. Let me go back and find it. I must have skipped it. Should be on this page. Let me make the page smaller. Random process. Law of large numbers. There is a box that has the definition of probability in it, and I don't know where it is. Oh well. Let me go to the next page. Okay, now that's weird. I just showed this to the other class the other day, and there was, oh, I know where it is. It's not in the book. It's in the book, but it's not in a bubble. That was on a probability. There it is. Probability is a measure of the likelihood of a random phenomenon or chance behavior occurring. So I'm going to blow that up if you want to write that down, if you can understand it. Probability is the measure or of the likelihood of random phenomenon or chance behavior occurring. So you might want to write that down so you'll know what the test question is asking. But as far as probability is assigning a number to between 0 and 1 to a prediction based on logic, deduction, experience, mathematics, or statistics. Okay? Notice I said between 0 and 1. That means that you will talk about probability in terms of decimals, not percents. Percent is chance. We're not talking about chance. We're talking about probability. So we're going to be speaking in terms of decimals. The probability of an event happening looks like this. The probability of an event not happening looks like this. Probability of an event. Probability of an event not happening. This is called the complement. The complement is what makes up the whole. What's the complement of black? White. What's the complement of no? Yes. What's the complement of true? False. What's the complement of 0? 1. What's the complement of guilty? Innocent. Technically, it's not guilty, but we won't get into that. All right? Because we all know OJ was innocent, right? All right. So these are complements of each other. Whatever makes up the whole. Law of large numbers. What is the law of large numbers? The law of large numbers basically means don't half-ass do a job. Let me give you an example of what law of large numbers means. Let's say that I'm a quality assurance director. Anybody know what quality assurance is? Nobody knows what a quality assurance manager is or director. Or quality assurance. Y'all never heard the term quality assurance before. It's the person in the company that takes care of defective products. Does everybody understand that? So let's say I work at I'm the quality assurance director, Southeast director at Michelin. That means I probably bring home anywhere from 100,000 to 135,000 a year. Because I'm a what? I'm a Southeast director, all right? So I attend meetings every year up there at the Crystal Palace on 95 between Greenville and Spartanburg. And I got an office there, and every year I present the defective tire budget for Michelin in the Southeast. And in 2021, I predict that we will have $2.5 million of defective tires. $2.5 million in defective tires for 2021. 2022 rolls around, and I report that in 2021, $15.2 million were due to defective tires. Guess what I am? In 2021, I predicted to the CEO of Michelin that we were going to have $2.5 million of defective tires. In 2022, I had to give a report at that meeting that the defective tires in 2021 was 15.2 million. What am I? What am I in terms of Michelin Corporation? Fired. Why am I fired? Say it again, Mr. Hamby.
Because you didn't do your job right.
I didn't do my job right. Why? Because I was lazy and I didn't count enough tires to give a good what? A good prediction. Okay? Here in this report right here, I pulled 100 tires out of Sandy Springs. I pulled 100 tires out of Greenville. I pulled 100 tires out of, they call it Star down here, but it's not Star, but out of the Star plant. And I got $2.5 million would be in defective tires. Should I have pulled maybe 1,000 tires or 10,000 tires? Yes. The law of large numbers dictates the more you research, the what? The better. The more you do on research, the better. Statistics is not a place for LAD. And what is LAD? Lazy disorder. You cannot do good statistics and good probability with LAD. Because if you have LAD with your research, you're going to get fired if you're a quality assurance director. Now, let me explain the law of large numbers and probability. There's two types of probability. There is the physical probability, And there is the theoretical. The theoretical and the physical. What is theoretical? Well, somebody tell me, what is the probability of picking a king out of a deck of cards?
It's like 1 out of 13, I think.
It's 4 out of 52. Wow. 4 out of 52. Who said 1 out of 13? Miss Woodson?
No, I did, because there's 13 cards in a suit.
Okay. Miss Poor, do you have a deck of cards in front of you?
More or less, yeah.
No, I mean, were you looking through the cards when I asked you that question?
No.
No. How did she know that? Is she just psychic, or does she just know that there's 52 cards in a deck and there's 4 cards that are kings? She just knows it, right? From memory or from dealing with a deck of cards, right? That's theoretical. She did not look at, okay, I'm getting bad network, bad sound errors. Are y'all getting an error of bad network? Okay, something's going on. We may get cut off here in a second. All right. What is physical? Physical is you dealing or shuffling, pick, shuffling, pick, shuffling, pick, and you do that 10 times. And you write down each card you pick. And you find out that you got 2 out of 10 that are kings. Well, 2 out of 10 is 0.1. So the physical probability of picking a king out of a deck of cards is 0.1. Somebody take 4 divided by 52 for me and give me a decimal, please. You ain't got a calculator? 4 divided by 52?
0.077.
0.077
Yep.
or 08? 0.08. They're not equal. So, what does the large number rule say? The large number rule says the more physical probability you do, the more physical probability you go through, or I can't think of the word right now, that you attempt, the closer the probabilities will approach each other. Be equal to each other. Okay? Let me give you an example, and this example will bring it home. At MIT, there were 2 students that took a roll of quarters. That's 40 quarters. They measured the weight, the height, the how thick they were, and the balance of each of those quarters. Then they got an average. They took the average balance, the average thickness, the average height, the average weight, and they created a virtual quarter. In other words, from that roll of quarters, they made a virtual quarter. Everybody with me? 25 cents. They created a virtual quarter and put it in a computer program. Somebody tell me, what is the theoretical, and I don't know if there's an H in there. I always want to put an H in there. Somebody tell me. I think there's supposed to be. I may be wrong. I always want to put an H in theoretical. I may be wrong. What is the theoretical probability of tails with a coin? Okay, that's basic of the basic of the basic probabilities. Everybody in the room that's had probability should be able to tell me the decimal
50,
of point what?
5.
0.5. They took this quarter, virtually flipped it. Can anybody guess how many times they had to flip this quarter in the computer program to get a physical probability of 0.5? Anybody want to take a guess? Anybody want to take a guess? Really? You can't just shout out a guess? I mean,
6.
6. Anybody else want to take a guess? Miss Polar, how about you? Or Miss Woodson? Somebody, give me a guess.
8.
8. One more guess. Somebody give me one more guess. 2. It took that virtual quarter 10,000 or 100,000 flips to get a physical probability of 0.5. This is the law of large numbers. These two probabilities don't match with 1 or 2 flips. These probabilities match when you do 100,000 flips. So what does that say? Well, there's an old saying in life, and some of y'all that won't, some of y'all that agree with giving trophies to everybody may not like this. You get out what you what? You get out what you put in. So let's go back to the Michelin director. Did he put in a lot of work to do his report? Yes or no? And
No.
what was the result? He got fired. Does that happen in real life? Oh, hail to the yes. Now, I've never been fired before, knock on wood. And I contribute that to my daddy that worked me like a dog when I was little and taught me about a work ethic. And I'm trying to teach my son that, which is kind of hard to do with, growing up in the pansy, buttercup, what do you call it, snowflake generation. But I'm trying to teach him that if you don't work, you don't what? You don't get paid. Now, what in the heck does that have to do with probability? If you do crappy work in probability, if you do the crappy work, you will present crappy results. Will people know? Yes, they will know. If they don't know, they'll know by the next year when your report comes out. They're going to know. The large number rule states that if you do your research and you do enough research, your presentation or your prediction will be accurate. That's what the large number rule says. And if you do crappy work, you get fired. As the number of repetitions of a probability experiment increases, the proportion of which a certain outcome is observed, physical probability, gets closer to the theoretical probability. Now I'm going to give you the formula, and that's all I'm going to be able to do because, and you can work on 5.1 homework. The formula for both probabilities, physical and theoretical. Both probabilities, the formula is the number of times something happens over the number of times something can happen. Okay? Now we're going to stop right there. I've already taken the roll, so we're going to stop right there, and I need you to put that in your notebooks because we're going to stop right there. You can go ahead and probably start 5.1 homework, but don't be sad if you can't finish it because I've got to cover sample space next. And some of you may not know what a sample space is. If you want to read the rest of 5.1, you can. And I will see y'all Thursday, okay? Y'all have a good day. See
Have a
y'all.
good day, Hubert.
Bye-bye.
Did you get me as here?
Yeah, I got everybody. Everybody was here. Yeah, you came in right when I did the roll. So you're good. Everybody was here. See you.